everybody. Hello, Facebook world. Hi. I hope everyone is doing very, very well. All right, let's see. Things seem to be looking good on my end. I got to check. So Facebook had a little bit of an update. I don't know if some people noticed, and it was a little angry with me and we were fighting a little bit, but I think I got it figured out. So I think I got it. At least I hope I got it. That would be really not fun if I didn't get it after all that work. So hi, everybody. I hope you're doing really well. As always, oh my goodness, the Graves family's entirely here. So it's so good to see you guys. Thanks, Brian. It's good to see you. All right, we're doing good. So my name is Miss Laura. I'm your education manager here at the South Carolina State Museum. Now, I am not at the State Museum right now. I had to take care of my little one tonight and I didn't have time to make it back to the museum, so I'm coming to you from my porch. But this is also a good way for me to talk about why we had to change things up a little bit, and I'll get to that in just a second. I do want to, of course, say thank you to Boeing for being our loyal sponsor for this event and our observatory and all of the amazing astronomy stuff we do. We could never do it without them, so thank you so much to Boeing. Thank you to our amazing members for sticking through it. We're finally starting to get back to some more things going on at the museum, so we're looking forward to not just seeing you, but just getting to experience events again and things like that. They're smaller and still a little bit different, but we're excited to have them. And then we are also super to have our Astro Kids on board. We have one of our Astro Kid families here, probably our most loyal Astro Kid family here. And we are just so excited that you guys are still with us and still hanging in there and doing things with us. I know that there are sometimes questions about what to do with Astro Kids, and Miss Kelsey is shooting out emails as quick as she can get them. And I know that she's getting in touch with everyone shortly this week. So just be patient, wait for Miss Kelsey. And if you have any questions, type them in the chat. So like I said, my name is Miss Laura. I'm your education manager here at the South Carolina State Museum, and I do anything weird and funky, and I also get to work with the super awesome Astro team. I get to be part of it, so I absolutely love it. And we're coming to you every other week now, and we're also coming to you on Tuesdays, and it's going to be at 6:30. Now, the format for this is going to change a little bit as we go. We can't really show you a complete live stream anymore because, as you can tell, I'm out on my porch and it is sunny, sunny, sunny. It is very bright and beautiful and not exactly star watching time right now. In order for us to be able to see stars during this time of year, we would have to start the live stream at like 9 o'clock, maybe a little bit later. And that is pretty late. I don't know about some of you, but I have a toddler and my bedtime is early as I can make it be. And it's just kind of late for a lot of families. So we had to make some adjustments. These adjustments are going to last throughout the summer. And then in the fall, we'll reevaluate again and see if we can make things work so that we can do more live stuff. It also gives us the flexibility to be open in the museum. It gives us the ability to do some rentals on Friday nights and things like that, maybe get some revenue in and help us maybe hire some more people to do things. So we're kind of thinking about the entire museum and different programs and things that we might have. So I know it's a little weird, but we're making it work and we're doing the best we can. And if you have any suggestions, just feel free to type them in the chat or shoot me an email. So I think that's all I've got to say. I am going to pass it to Mr. Matthew and Miss Liz really quick. But before I do that, if you are new to our Space Team live stream, I think that's how Miss Thoroughkill wants us to say it, Space Team live stream. If you are new to it, all we ask is for you to be kind and courteous in the comments. Always kind and courteous in the comments. And if you are curious about anything, it can even be off topic. If you're curious about anything, type it in the chat and I keep track of it. I type it up and everything. And I write them down and I ask them during our session. And if it doesn't fit or doesn't belong, sometimes I'll ask it at the very end, or sometimes we'll hang on to it and it might create one of our other sessions. So that's something to keep in mind. You could inspire one of our Space Team live streams. So, but I'm going to pass it over to Liz and Matthew for our new bi-weekly astronomy news catch up. So what's happening in Astro News, Liz or Matthew? Hi.
Hey, hello. Hello. So my name is Liz. I am the planetary manager here at the South Carolina State Museum. And something super duper schmooper exciting happened yesterday. If you've been following space news, it involves the first ever flight of a helicopter on another planet. So I'm going to go ahead and share my screen here because I have some snazzy pictures to show you. Let's bring that up. Okay, so this is actually a selfie that Perseverance took of itself with Ingenuity. So just a quick recap, back on February 18th, NASA landed another rover on Mars called Perseverance, or Percy for short, and it brought a buddy called Ingenuity, that little helicopter you see off into the distance there. So Ingenuity was kind of tucked underneath the rover, just under the belly of the rover, and then rode it down to the surface there. So let's go on to the next picture here. So there is the Ingenuity helicopter. This is just a sequence of images that shows how it was stowed on the underside of the rover. So this was taken a few weeks ago. It was stowed sideways and then just kind of slowly unfolded, and then its legs kind of flop down. It kind of looks like it's being birthed from the underside of the rover there. And then it kind of hovered a little bit above the surface, just a few centimeters, and then Percy set it free. And that last image there is of the rover all by itself. Let me back up here, back up a little bit. That's okay. So the rover was all by itself there for a while, and it had to be on its own. It couldn't use the power from the rover anymore. It had to use the solar panels here. In the zoom in image, you can see the solar panels on top, and it had to survive some bitter cold nights on Mars, where it got down to about minus 130 degrees Fahrenheit. So that's pretty chilly. And then what happened is the helicopter had to go through a series of tests. So NASA did this very carefully, very slowly and deliberately. This is the first time we're ever doing this on another planet. We can't be there, you know, it's millions of miles away, and all has to be done remote. So this image right here, this little animation just shows one of the initial tests where they unlocked the rotors and it did a wiggle test. So this is it wiggling there, which I thought was
Wait, what's a wiggle test? Because we do a lot of wiggle dances in our house. What's a wiggle test?
It's what it's doing right here, just moving its blades a little bit, just making sure they can swing freely. This is right after they unlocked the rotors. There are two rotors there. They're about 4 feet-ish in length. Very light. This helicopter is about 4 pounds on Earth, about 1.5 pounds on Mars. So the whole thing is very light. It's pretty compact. So it's just wiggling its rotors there a little bit just to make sure they can swing freely. And then after this, what they did is they tried to do a spin up test and spin the rotors faster. And then they started to run into some issues. So, and it's nothing.
Liz, why do they do that? Why are they testing the motors and stuff in phases?
So I just test it, you know, a little by one thing at a time, just so if you run into an issue, you can, you know, deal with it one thing at a time. Because basically everything was tested here on Earth to the best of our ability. So when Ingenuity was on Earth before it left for Mars, they tested it in this chamber where they tried to simulate Martian conditions as best they could. So the atmosphere is very thin. It's about 1% as dense as that on Earth. They tried to simulate Martian gravity as best they could. Ultimately, though, nothing replaces the actual test. So I think what a lot of people it hasn't really sunk in is that this first flight and everything leading up to that, this is really the final test, because you can only simulate and you can only test so much on Earth. And this is really the final test, is just really being there on Mars and really flying on Mars. And so you're actually seeing the engineering process live, I mean, as they do it. So they send the rover there, it lands, they slowly unpack it, make sure everything works like it should, one thing at a time. And then you start to gear up for that first flight. So they did run into a snag. They were going to fly this initially a couple weekends ago on April 11th, but they did hit a little snag and they needed to do a software update. And that's not really unusual. Yes. Uh-oh, Ms. Laura, you're muted.
There we go. So Brian has a question. He's saying, I haven't seen anything about how Ingenuity will know its position on Mars. And that's a curious thing to think about. It has accelerometers and gyroscopes and things like that to maintain stability, and probably a barometer for an altimeter. But with no real magnetic field on Mars, I'm sure a compass is not going to work, and there's no GPS system on Mars. So does the home in on the rover use some sort of inertial navigation? So how does the rover know where it is and how to fly? Do we know that?
I'm not entirely. I know it has cameras. It's pointed at the ground, and it uses that to kind of track where it is. The other thing about this is it is a tech demo, and it is not going to fly very far. So so let me go past the wiggle test here. This is so basically, just to backtrack a little bit, they did a software update, which, not a big deal. They discovered something that they didn't like, so they did a software update, and then had to test that out, and it all worked. So this is the first flight here, and I'm going to run this video. So this doesn't show it taking off and landing, but it shows it hovering there above the surface. And it does have cameras that are pointed down to kind of look at the surface and just track where it is. This first flight was really just taking off and ascending to about 3 meters, which is, or 5 meters, which is about 15 feet. And then it turned a little more than 90 degrees, 96 degrees, and then it came back down and landed almost in the exact same spot. So that was just
It sounds pretty tough to do. That sounds good.
Simple first flight, because if you can't do that, then you're not going to travel horizontally. If you can't at least, lift off and hover and land safely.
Yeah.
So the only thing
I have a friend, I know we were talking about it a few weeks ago. I have a friend who's a pilot, but he also flies model planes, like smaller planes. He always tells us, I have so much more problems with the smaller planes because I'm not in it. I can't feel it. It's harder to fly with just a controller. I can't imagine doing it on another planet with a huge delay and like a different atmosphere and everything.
Yeah, it's really, really hard to do. So and this doesn't show the full video of it taking off and landing. And yeah, those rotors have to spin very, very, very fast. They spin, I guess a helicopter's rotors spin about 400 or 500 revolutions per minute. This is about 2,500 revolutions per minute. So in order to fly on another planet, you have to have those rotors spin very, very fast to get some lift, and the spacecraft has to be very, very light. Let me try.
Well, that is so cool, Liz.
Move on
That's
here.
so neat. I know you were really, really excited about it. Did you have anything about Ingenuity?
Wait, sorry, what was that?
Did you have anything else you wanted to show us about Ingenuity? Y'all don't understand. Liz has been talking about this for like years.
So one last thing about it is this is a picture. Speaking of the cameras that were pointed down, this was a picture of its own shadow that was taken pointing down, so it can kind of like track where it is. And it has an altimeter in it to figure out how high off the ground it is. But the next step is this week, maybe Thursday, but we'll see. They're going to try to fly it horizontally and then in increasingly farther distances. So this is just the first test flight. There are more test flights to come. And again, it's just going to travel maybe a few hundred meters, and then that's it. It's not going to soar over the landscape. That's for the future. What we do here is going to help us build those types of craft that will soar over the landscape. And the coolest thing that I'll leave you with about the helicopter is as they get to the end of the testing window, which is the end of this month. This is the month of Ingenuity, where Percy's really, before it goes off exploring, it's going to wait for the helicopter to complete its test flights, because it's been taking all the images and the video. They are going to push that helicopter to its limit, which means we are going to, when they haven't decided what that means, if it's how high can it go, how far can it go, how fast can it go, but they are going to basically, they intimated, push it to its breaking point, which means we might see a helicopter crash before the end of the month, intentionally, just to see like how far we can go. So stay tuned for that. Because
I know you can't wait for that. That's awesome. That's really exciting.
You need to know like what its limits are. When you build the version that has the science instruments on it, and they are getting ready to design a helicopter that will fly on Saturn's moon Titan. So it's called Dragonfly, and that'll be later at the end of this decade. And so what we learn here might help, it's a completely different environment, but it's flying on another world. So
one small flight for robots, right? One small flight for robots leads to giant leaps for people kind. So we're excited about that. And we appreciate all that Ingenuity and Percy are doing for us, because they're leading the charge and doing a lot of good. All right, well, that's awesome. That's what's happening now in Astro News, I guess. Right? That was your big thing. And every 2 weeks when we do this, so our next one is May the 4th. So May the 4th be with you. We're really excited about that. You'll have another Astro News update. So Miss Liz, did you want to start? I think we're talking about Earth Day this year, right? Because we've got Earth Day between this one and our next one. We have Earth Day. And Earth is a planet which totally counts in astronomy and is arguably probably the best planet because we're all here.
Yes, it is. So I wanted to briefly just give a nod to Earth for Earth Day. So I guess that's kind of current events as well. So Earth Day is on the 22nd, so just a couple days from now. And in my virtual sky tour, which will get released this Thursday, I'm going to talk about how NASA uses space to study the Earth. But what I thought about doing here is just to kind of acknowledge what a special place this is and kind of link this into exoplanets a little bit, because we've been searching for other planets throughout the galaxy, but one of the big things that we would love to find is another Earth. And so that is part of the search for exoplanets, and just, is there another place out there that's like our own home? And so as we look around other stars, there is this distance away from the star called habitable zone.
I was going to ask you, how do you know that? How do you, that's a lot of stars and a lot of possible planets. How do you know when something might be right for another Earth-ish kind of planet?
So what they're looking for is they're looking at the distance away from a star that a world would have to be for liquid water to possibly exist on the surface. So they're looking, no matter what type of star it is, it doesn't have to be a star like our own. It can be a dimmer star like a red dwarf. It can be a hotter star. There's a distance away where if you can find a planet that's orbiting a certain distance away, and just based on how much energy you're getting from that star, theoretically, water could exist on the surface. It doesn't mean water does exist on the surface, but it means it could potentially, because a lot depends on the planet itself, what its atmosphere is like. Venus is arguably in the habitable zone, but you can't build a habitat.
Yeah, we obviously we don't want to go.
It's got a thick atmosphere that traps in a lot of heat. It's got acid rain, and so it's
stinky too.
Yeah, I know. And the moon is a world in the habitable zone, but you can't really live there without bringing your own air and water and stuff. So just being the right distance from the sun isn't everything, but that's a start. So we are trying to look for other planets like our own, and we haven't found one yet. which doesn't mean they're not out there. They just might be super tricky to find. But I just think it makes us appreciate our own world that much more, seeing as how we haven't found a place quite like this one.
We're pretty special on a pretty special planet.
We are. It is pretty special, and that's why we want to take care of it, because even if there are other Earths out there, it's not easy to get to them. So they're all going to be really, really far away. This is just a quick nod to the TRAPPIST-1 system. It is a system of planets orbiting around a star that's smaller than our own, but it has, if I can count, 7 possible rocky planets that kind of lie within a habitable zone. So maybe one of those is like Earth, maybe not. We don't really know, but we're looking for them, and we found, I believe it is, and I wrote that number down, we found 165 terrestrial exoplanets, meaning they have solid surfaces, but they're not all necessarily in a habitable zone, and they're not necessarily like Earth. One other term that I thought I'd throw out there is sometimes when you look at the search for Earths, you'll see the term super Earth, and that is a little bit of a misnomer, because just because it's got that term Earth in it doesn't mean that we found another Earth. It's just a
What's a super Earth, Miss Liz? What is a super Earth?
It's a super Earth. It's got superpowers. It basically just is, it's not as big as the giant planets. It's a little bit bigger than Earth, but closer to Earth in size than the giants. But it doesn't mean that, it's habitable or anything like Earth. And it could be solid and it could be not solid. So, that's just another kind of terminology thing that gets thrown out there. So basically there's no place like home. We're looking for other Earths because we just want to know if, how unique we are. But so far this is what we got. So this is what we want to take care of. And even though it's a planet literally right under our feet, there's still a lot we don't know about it. So happy Earth Day, I guess.
Happy Earth Day.
Your local planet.
Liz, you did say something about like finding water on other planets, but haven't they found ice on other planets?
We found ice, but you really, really want to find liquid standing water. And right now, even in our own solar system, this is the only planet we know of with standing liquid water. Even though the moon Titan has standing liquid, but it's not water, it's methane and ethane. They found ice on the moon. There's probably water in ices on Mars and whatnot, but not standing like lakes. And that's what we as far as we know, what we need for life. So that's why we want to see if there's other aliens out there, and do they want to be friends? And
we don't know.
Nice to have a neighbor to be pen pals.
Well, that is really cool, and I love that you wanted to bring that up this time around, because it's I feel like Carl Sagan in one of his shows was reminding all of us, like, it's the only Earth we've got. It's it, and we gotta love it. We gotta take care of it. So
yeah,
eat and recycle, and let's keep it healthy and clean for all of us. So thank you, Miss Liz. That was awesome. So now we're going to kind of flip gears a little bit, but it still makes sense, because all of these things, Miss Liz was reminding me earlier, all of these things happen in April and around April. And we're talking to Mr. Matthew today about the M87 galaxy and black holes. So Mr. Matthew, what do you got for us?
Well, I'm the one who has superpowers, because I'm
true.
talking about black holes.
We don't need a super Earth. We have Matthew.
Yes, that's right. Well, so today you're gonna do a little recap on the black hole at the center of the galaxy M87. This has really been in the news a bunch, but there's actually a cool new little twist to it and I think the word twist is actually kind of apt, because you'll see what I mean when I show you my final picture. There's a new version of the image out that really has some cool things about it. So we'll get there at towards the end. But for now, I just wanted to kind of show you, if I can find the right the right thing to share. Up, up,
Did I
up,
make you a
up.
co-host?
No, I think it
Okay.
just is my window did
Mm,
something weird. Ah, there it is. There it is.
there you
There it
go.
is. Okay, I gotta love it. Technology.
I know before we went live, everybody, I was fighting with Facebook and I was messaging. I don't know what's happening.
All right, now I can share what I wanted to share. Now let's see if I can make this big and pretty for you.
Oh.
Woo! I know, isn't that cool? Oh, let's see. Why is there? Well, there we go.
Beautiful.
I know, isn't this pretty? So it's kind of cool to start this whole thing about this black hole picture. I'm just going to actually show you the black hole picture really quick. We're going to come back to it, but just going to show it to you. So if you're like, what are these freaks at the State Museum talking about? Well, that was fun. We're actually talking about this right here. So you may be familiar with that image. When it was released back in April 2019, it was really kind of a big story. So let's now back up to the galaxy. So the galaxy that it's in is called M87. And astronomers, oh, I think we have a question.
Why M87?
Oh, yeah, you know. So actually, astronomers love to come up with very creative names for things. Not. So there was a French astronomer named Charles Messier, and he liked to scan the skies looking for comets. And he kept finding these objects that were fuzzy and they looked kind of like comets. And so they would stop distracting him from his comet searching. He made a list of them. There are 110 of these objects. They're his nuisance objects, I like to call them. And what's funny is Messier is not remembered for his comet discoveries. He's remembered for his list of 110 nuisance objects. Now, how about that for funny?
That's so good. I love that. That's a great fact.
So this galaxy is number 87 on Charles Messier's list of nuisance objects. So this particular nuisance object is actually kind of cool and wild. It's a galaxy about 55 million light years away. So that's not a super distant galaxy, but it's still pretty far away. It's in the center
It's
of what
not just a car right away.
Yeah, that's right.
Not a quick rocket right away.
So it's actually in the center of what we call the Virgo galaxy cluster. Turns out the Milky Way is also part of the Virgo galaxy cluster, but we're out the very outskirts. So this is kind of like downtown galaxy cluster right here, where this giant galaxy is. It's an elliptical galaxy, so it's different from our galaxy. And it doesn't have spiral arms. So I have two pictures here. The first picture, the one on the left, is a picture that we took with our telescope here at the museum. So the telescope right behind me. And the picture on the right is a picture of the same galaxy using the Hubble Space Telescope. So we want to kind of compare and contrast. Why do these images look so different? So do they look different because of the telescopes that took them? Because they were looking at the galaxy at a different time?
Yeah, they do look very, very different. The one on the right, the Hubble one, is definitely a lot brighter.
Yeah, why is that? Why do we think that Hubble picture is a lot brighter than the picture through our telescope here at the museum?
I'll let you know if I see anything in the chat. If anybody in the chat has any ideas as to why one is brighter or one is not, and why we see different things, go ahead and type it in and I'll let Mr. Matthew know when we get it.
All right. Well, I'll just kind of give it away a little bit. And one of the things that's different is that with our telescope, we're looking at this rather faint galaxy in the middle of a city with a lot of light pollution. And that really affects what we can see in terms of more distant and fainter objects. Of course, the Hubble Space Telescope is in low Earth orbit, and it's far above the atmosphere and isn't affected by light pollution and all of that. So you're going to get a much brighter image from Hubble. And also, it's a bigger telescope. We have a 12-inch telescope here at the museum. This telescope, the Hubble Space Telescope, is a about 2.5 meters across. That's how big its mirror is. So one of the things that I see a hand. Do we have a question or a comment?
We do have a question. What is coming out of the image in the Hubble Space Telescope?
Do you know what's so funny is that both of the questions that we've had actually were segues into exactly what I was about to talk about. So whoever is out there in Facebook world, you are reading my mind. So that's a little bit, well, we are the space team, so mind reading's probably going to happen.
Just a little bit.
Yeah. All right. So yeah, what is that thing that's coming out of the center of the galaxy? It's this stuff right here. This is a giant jet of material that's being flung out from the black hole area. So the black hole is in the center of the galaxy. So kind of like in our telescope picture, kind of like right in here. And then in this picture, like right in here. And I am even wondering if we can see the jet in our picture just a little bit. Like I see this little thing sticking up right here. I'm wondering if that's the jet. I'm not quite sure, but it wouldn't surprise me if we caught a little bit of the jet. But it's this giant jet of material that's coming out from the center of the galaxy. And it's basically stuff that's trying to fall into the black hole, but doesn't quite make it. And it gets shot out into space really, really fast. And it gets really, really hot. So a jet like this, I believe this jet's somewhere like around 5,000 light years long. And some of the material in it is moving not that far off the speed of light. So pretty crazy thing.
That's pretty fast, I think.
Yeah. And actually the cool picture at the end with the new twist to this whole black hole story is also going to tie into this jet thing again. So are we ready to go have a look at the black hole itself?
I think so, yeah.
All right, let's see if we can make our PowerPoint behave itself like it wasn't earlier. All right, so here's the picture. This may be familiar to some of you, but may not be necessarily. I like to think that it kind of looks like a maple donut.
Ooh, that's a good one.
Yeah, it's a maple donut.
That's my favorite donut.
So I know I enjoy maple donuts too.
They're my favorite. It looks like the Eye of Sauron is what some of our campers say.
Yeah, it does. It looks kind of evil, doesn't it? Yeah. So here in the center with the eye right here, this area is usually referred to as the shadow of the black hole. And I have to say that I don't fully understand what that means. But we're basically not looking directly at the black hole, but we're looking at this area kind of nearby. And then all of this stuff right here, kind of the donut part, this is hot gas that's being swirled around the black hole. And we're seeing the light that gas is giving off. So that gas is going around in kind of a whirlwind kind of pattern around the black hole and heating up a lot. And actually, little tease here, this gas actually has a little bit to do with how those jets formed. So again, maybe familiar to you, maybe not, but this is our first real look at the area around the black hole. The astronomers that took this picture are hoping to get a picture of the black hole on the center of our galaxy at some point. Yes, we have a black hole in the center of our galaxy.
Is that a scary thing? I think that's the main question we get from some of our students and campers. It's like, we have a black hole in our galaxy. Are we going to get eaten? What's happening?
That's right. Is it going to eat us? Yeah. Well, no. So the black hole in the center of our galaxy is about 26,000 light years away. So it is way too far away to cause us any problems. So even right now, our black hole in the center of our galaxy is pretty quiet. Even if it were to start eating stuff again and kind of turn on again, it's too far away to really cause us any problems. So I would not worry about that. But it's very common for these large galaxies to have black holes in their centers. It's more the rule rather than the exception. This particular black hole is about 6 billion times as massive as the sun. Yeah, it's big. Yeah.
Do we have any idea how a black hole forms? Like, where do they come from or how are they made?
How do black holes form? Great question. So we have an idea of how smaller black holes form. So what we call stellar mass black holes form when a really big star explodes as a supernova at the end of its life, and the core collapses down into this area where matter is packed so tightly and densely that nothing can get out, not even light. So that's how we get these sort of small black holes. They're formed when really massive stars die. We're really not so sure about how these black holes form in the centers of galaxies. So that's kind of an active research topic, is how do galaxies end up with these supermassive black holes in their centers?
And do they always stay put or do they move? Like, are black holes always stationary?
They maraud around and they go and, look for planets to eat. Nope, just kidding. Yeah, so like the black holes at the centers of galaxies are going to stay right there. So it's not like we have these like black hole monsters going around space waiting to devour
It's not like,
planets.
is it Apple products that have, or maybe it's Windows that have like the thing, the little whole circle that moves around as your screensaver and like eats things? It's not like that then.
Yeah, or it's not like a Pac-Man going around like, the old video game.
Kimberly would like to know if the black hole somehow got bigger, that the one that's in the center of our galaxy, if it got bigger, would it be a problem for us?
So if our black hole were to, as I said, turn on, that's kind of the words I like to use. Again, that means it starts to actually pull material in. It would actually start to very slowly increase in mass as more stuff gets pulled in, but not anywhere near enough to cause us problems here on the Earth. We are just too far away from the scene of the crime for it to be a problem.
Yeah, and then last but not least, I think the other big question we always get is, but what happens if I fall in a black hole?
You turn into a long strip of spaghetti, and that is the end.
You get spaghetti eyes.
Spaghettified. Yep. Actually, spaghettification is this getting stretched out by the gravitational forces of the black hole. That only happens if you're going into one of those smaller stellar mass black holes. If you're going into one of these supermassive black holes, you'll actually cross what we call the event horizon, which is kind of the point of no return where you actually enter the black hole. You actually pass the event horizon and everything seems kind of chill. You don't know that you have, because these black holes are just so much bigger and the gravity is spread out over a larger area. So you pass through the event horizon and you don't know that you're stuck until things start going all wrong. And you start,
Very interesting. All right, did you have anything else about black holes you wanted to show us?
I have couple things really quick here. A lot of people ask us about how this image was taken.
Oh,
so
I
do have a picture of the radio telescopes around the world that took this picture. So a lot of times when people look at a really amazing space picture like this, the first thought is, oh, Hubble took it. So it's actually this group of radio telescopes instead on Earth, and they all pointed at the galaxy at the same time and stared at it for about 2 weeks, and then the image was combined with a supercomputer. So here is
time to look at something.
Let's have a look at our last picture, the picture with the twist to it.
So, oh yes, I forgot the twist.
The twist. Do you see the twist?
Yes, I see the twist.
Woo, the twist. All right, so
like a crawler.
There have been some more work done on the data that form the image, and it turns out that the light in that maple donut part of the black hole is polarized. So
what does that mean? Polarized?
What does that mean? I'm wondering if Liz could actually, you may be able to explain polarized light a little better than I can. So Liz, feel free to jump in.
Sure. So polarized light, so if you just think of just light in general, light is a wave. It's an electromagnetic wave, so it's energy and it's going up and down. And light that you usually get, you know, like from the sun and whatever, it's oscillating in different ways. Some's going up and down like this, some are oscillating back and forth like this. There's no preferred direction. When you talk about polarized light, you're looking at light that is, all the light in this image is going up and down in the same direction. So if you think about polarized sunglasses, they're only allowing light that's going up and down, those wiggles going up and down in a certain direction to pass through, and that cuts down on glare. And so that can kind of sharpen your image there a little bit. So all the light in this image is wiggling in the same direction.
And that's why we get these things that look like swirly lines. So what's cool about this is, remember the jet that we looked at in the center of the galaxy earlier? So whenever you have polarized gas like this, what that means is that there is, or polarized light from gas like this, what this means is that there are very strong magnetic fields at work. And in some cases, the magnetic fields are actually overcoming the force of gravity around the black hole and flinging that gas out into space. And that's how we got that jet here, is those magnetic fields just flinging that gas out of the galaxy at a very, very high speed.
Yeah.
So yeah, such a cool picture, and we're going to be learning a lot more about it. So yeah.
And black holes are definitely one of our more popular subjects. Don't worry, you guys, we will do a black holes session. Don't worry, it'll happen. Space Team live stream, black holes.
Yes.
We will definitely do it. Don't worry, it'll
And
happen.
also, we have a planetarium show called Black Holes. So the observatory and the planetarium are now open. And so you can come see the observatory during the daytime. We're looking at the sun, safely, of course. And we are running planetarium shows, and one of those is a black holes show. So if you want to learn about black holes, come see us.
And if you want to see the spaghettification process on a fake astronaut.
Yes, yes, definitely a fake astronaut. Yep.
Well, Matthew already started my closing information. That was one of my things. So thank you, Matthew, for starting it off and everything. And
cool.
I hope everybody had. Oh, good.
Turn off my screen share.
Okay. But everybody, thank you for joining us. I know there weren't a whole lot of y'all, so if there are people watching this on record or anything, thank you for seeing this at any point in your day that you had some time. We hope you had fun. Next time is going to be May the 4th. We are going to be joined by our director, Tom Falvey. He's going to be taking us through the telescope gallery, and we're going to be looking at some really cool stuff and really fun information there. And we're actually going to be going around the gallery, so we'll be on the move. We are so happy to be able to do this again. Thank you for your support. Just viewing it and watching it and sharing it helps us out. So thank everybody so much for doing that. And like Matthew and Liz said, the planetarium is open, the observatory is open, the museum is open. We are having a great time. We've been able to see a lot of people during spring break, and we have summer camps open as well. We're doing trivia night pretty soon. So lots of cool stuff coming in. I did have a question pop in about summer camps. Summer camps are only at about 50% capacity. We can't take everybody. So if you want to sign up for summer camp in the museum, you need to do it now, because instead of taking about 85 to 90 students, we're only taking 40. So very limited. But observatory and planetarium, wide open. We would love to see you, and we hope you have a wonderful week, everyone. Bye.
Bye.